Okay, so I'm hoping you went and saw those videos on wingsuit flying. I mean, it's an amazing thing. It's an amazing thing. I am going to add the Felix Baumgartner problem to your thing. I forgot about doing that. Okay, so let me write down Felix here. I've got him right here. There we go. All right, so let's move on. With wingsuits, you will decrease the terminal velocity to about 60 miles per hour. Okay, but you'll still need you can. But that's when they raise up and they fully. But when they bring the flaps in, they increase their speed to, as they said Steve Croft said in that 60 Minutes video, to 140 miles an hour. But they can slow themselves down to 60 miles an hour. Okay. Here's one way of looking. You come into this big tube. These guys can fly. I mean, they can be pretty precise. This is an idea, but they actually did a better job. They've, as you'll see, as you watched Gary Connery, the crazy Brit, he flew into those boxes, but he was going about 60 miles an hour. That was his entire vector, I guess. So still hitting those boxes at 60 miles an hour would hurt. All right, so here's Felix Baumgartner. He did the Stratus thing with Red Bull the other day. He jumped up in the air there. You see that I'm getting meetings. I keep forgetting to turn off my darn Outlook when I'm recording you all. So we will definitely look at, he flew 22 miles or 3,500 kilometers, and he did it in 10 minutes. We're going to figure out how fast, what was his average speed while he was flying along. Okay, that'll be pretty interesting. Okay, and I'm also going to add a question on Gary Connery. If he comes in at 60 miles an hour and it looked like he stopped in 3 seconds, what was the acceleration on him caused by those boxes? Ouch, that would hurt. Okay. So this is about coming to a stop. This would be like Gary Connery coming to a stop. What was the force needed to stop him? We're going to look at this, okay, for those boxes. We're going to assume that he was able to get down to about 60 miles an hour when he came in. And I'm going to assume that he stopped in about 1.5 seconds, it looked like, okay? And so as he plowed through those boxes, taking 1.5 seconds, we're going to look at the force that was acting on him when he came to a stop. That'll be interesting. So how would you calculate the force? Well, you take the kinetic energy. I have you compute the kinetic energy of a few things in this. Equals the force times the distance. We'll have to calculate about how many feet it took him to stop. We might be able to do that. I don't know. All right, like I said, I'm thinking about this. So we can calculate his kinetic energy coming in there, and then the distance as he plowed through the boxes that he went, looked like it's probably about 9 meters, and then we can figure out the force that stopped him. Okay, so you take the 1/2, and see, my boss liked to, when he did these things, I like to just go ahead and get this number, and then divide by this number, and then you're done, instead of putting it all together like that. So that's an incredible amount of force for the Flash to stop in that short amount of time at running 500 miles an hour. Luckily, he was only going 60 miles an hour, which we know 0.447 is our conversion. So let's go ahead. Let's see what else we got. And now we'll talk, and then the last thing we'll talk about is hockey. Okay, and I will go through this mini quiz 5 with you so you can see what it looks like. Okay, out here. This is slide 2.